Alright guys, so here we are in the lecture number 9 of the linked list series. Welcome back. This is your very own Mascota this side. Hope you're doing extremely well. Now, in the previous video we discussed about circular linked list. Now the question I have for you today is not exactly for a circular linked list, but it is type of that. Right? So what does the question say? The question says that you haven't provided with the head of a linked list. As I said you before also that in most of the cases you will be provided with the head of the linked list. Now the question says that it might be possible that the linked list contains a loop inside it, contains a loop. See, I am saying that loop is different from circle. Loop is not equals to circle. Just keep in mind, right? Loop is not equal to circle. So the question says that it might be possible that the loop, linked list contains a loop. For example, consider a linked list 1, 2, 3, 4, 5, 6, and then connect 6 with 3. Connect 6 with 3. As you can see, it is not a circular linked list. Why? Because tail is not connected to head, but it still contains a loop because 6 is actually connecting to any middle element, right? Now, the question says that you have to determine whether there is a loop or there is no loop. You have to tell me whether there is a loop or there is no loop, right? The question is fairly simple, and I don't think that you must be any confused at any somehow about the question, right? So let us discuss how can we solve it. Let us discuss how can we solve it. See, believe me, if you will follow one of each step of mine, then you will surely get to the answer, right? So consider this link is only, right? This link is as your input. How can you determine? How can you determine? Suppose this is your head. This is your head. Now, the first condition is same of the circular linked list and the loop. The circular linked list says null is not possible. In the loop also null is not possible. I don't want to justify why, because it is fairly in front of you. This example is a live demonstration why null is not possible in the case of a loop or in the case of a circular linked list also, right? Null is not possible. This is our first observation. Moving on, how can I find? How can I find? Suppose I keep my temp here. See, I am also giving you a proper benefit of the linked list that most of the time, like 99% times, temp traversal, that is temp traversal, using a temporary node for traversal is the key to the solution. Is the key to solution. Is the key to solution. In the case of linked list specifically, right? Now, how will we move forward? See, null is not possible, right? So I will say, let us traverse. Let us traverse. Temp is here. After the temp will come here. After the temp will come here. Temp will come here. Temp will come here. Temp will come here. Now moving on, temp will come here, right? At this point, when temp again comes here, I am mentioning the word again. When temp again comes here, I should be just alarmed that there is a loop because I visited a node twice. My approach is visited a node twice, and that is where I crack the code. I have to keep an instance. I have to keep an instance whether the node has been visited or not. Whether the node has been visited or not. So how can I do that? I can create it. I can create a map for it. I can create a map for it, or I can create a set. What will I do? What will I do? Suppose I am drawing the linked list below. So this was my linked list, right? 1, 2, 3, 4, 5, 6. Now 6 next is 3. This is my linked list, right? I am saying your head is here. Keep your temp here, right? Keep your temp here. Now start traversing. Start traversing. Now what will you say? Let us try it with a map only. Suppose you are here, temp. Move to the next. Temp comes here. But before moving, insert this node into your map. So map now contains my one node. Temp comes here. Temp move to 2. Let 2 inserted, move here. 3. 3 inserted, move here. 4. 4 inserted, move here. 5. 5 inserted, move here. 6. 6 inserted, move here. 3. Now, before inserting 3, I will see that 3 is already existing in my map, and I can say if 3 is already inserting in my map, then I've got my loop as 3. I've got my loop as 3 is again repeating, and whenever element is repeated twice, that means this is a loop. Also, there is a one more problem solved for you, that 3 is the starting point of the loop. Whenever you encounter a visited node twice, that means starting point of the loop is 3 also, right? But that is not the problem for today. We have to discuss about the if there is a loop or not, right? So we will be discussing starting point again in some of the later videos, right? Now 3, right? 3. Okay, now this is a fairly simple approach. What have you done is you have run a loop. Temp is equals to head, temp is equals to head. Now while temp equals to temp is not equals to null, well, temp is not equals to null, what will you do? You will just say insert if mp dot find temp is not equals to mp dot n. That means we have found the node is not equals to mp dot n. In that case, return true that you have found a loop. Return true. Otherwise, what will you do? Mp of temp equals to 1. That is mark it as visited in some sort of way. Moving on. But if temp equals to null arises, suppose this connection was not here, this connection was not here, and it was null here, there was no loop, right? So when as soon as your temp becomes null, that means you didn't encounter any loop. So you can say return false here. Return false. This is your approach. This is your approach, but it is still not the optimized approach. We will optimize this. So stay in the video. What is the time complexity, guys? What is the time complexity? So you can see I'm actually traversing O of n time, right? Time complexity is linear, right? And space complexity also linear because I'm storing it to use map. I have a problem with this. My problem is with the space complexity. I want to reduce it. I want to make it constant. I want to do it in the constant time. Is it possible by any means? Is it possible by any means? Yes, it is possible. How? You are here at the Mass Coder channel, so everything is possible here. Optimized approach. Optimized approach. What will you do? You will say first draw the linked list again. So 1, 2, 3, 4, 5, 6. Now 6 is connected to 3. 6 is connected to 3. My approach is take 2 pointers. 2 pointers. Okay. Name one as slow and another one as fast. Right? As the name suggests, slow will move slowly and fast will move fastly. What will I do? I will say my slow is here, my fast is here. My slow is here, my fast is here. Okay. Slow will skip one node at a time and fast will skip 2 nodes at a time. Slow will skip one node at a time, fast will skip 2 nodes at a time, right? So just start doing. So slow skips one node at a time. So slow comes here, but fast skips 2 and goes to next. Fast comes here. Slow comes here, 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 fast comes at SF. That 3 contains S as well as F. 3 contains S as well as F. Now my conclusion is rather than head, rather than the first position, it is only possible to get S and F at the same position if and only if there is a loop. What is my conclusion? My conclusion is if we skip first time head occurrence, then slow and fast can point to the same node at same time only in the presence of a loop, only in the presence of the loop. This is my point. If we skip the first time head when we align slow and fast here, and then S and F moves, and if at any point of them time slow and fast are actually on the same pointer, that means there is a loop. But it might be the case that there is not a loop when 6 is actually connecting to null. In that case, which node will get to null first? It is obvious because fast is moving fastly, so null is actually more easy to fast. So this is my approach. What will I do? I will say my slow is equals to head, right? My fast is equals to head. Moving on, what will I do? I will say while suppose this is my linked list 1, 2, 3, 4. I keep my fast here until what iteration can fast move. So fast is moving first here, fast, and now it will stop. To avoid any segmentation fault, because my fast is moving 2 steps at a time, I want to see my fast is not null and my fast next is not null to avoid segmentation fault. To avoid segmentation fault, right? Because if fast next is null, suppose I'm saying my fast is here and I don't have my fast null, right? I don't have my fast. Suppose I want to reach two nodes away, right? This is my destination, but I see that this node is actually null. So this node does not contain anything, and I try to see the next of this node. That will give me segmentation fault, right? Because the thing is present here, and you are trying to see the next of this node. That is possible, right? So I am seeing while my fast and my fast next is not null. In that case, what will I do? I will move. So slow equals to slow next, slow equals to slow next, and fast equals to fast next. Not only next, again a next, right? Because it is moving two nodes at a time. Now I will see the condition if my slow is equals to my fast. That means I have arrived at a good condition. So in that case, return true. Otherwise, the bad condition. If fast and fastness, any of them is null, that means the loop is not there because we have reached a null node. So return null. This is the whole pseudocode, and I believe me, this is the easiest approach. The thing where it is getting an edge is it is running in O of n time and O of 1 space. That is why it is an optimized approach. Hope you liked it, and it is time for you to see the implementation, the code of it in the LeetCode section. So let us go. Alright guys, so here we are. Before starting with the code, I would like to request you to please subscribe to my channel because it has taken some serious efforts to construct this video and this playlist. So please give a subscription to my channel if you find it worthy. So list node star slow is equals to head, and similarly fast is equals to head. Now I will start my while traversal. So while my fast is not null and my fast next is not null, right? What will I do? I will first move them away. So slow equals to slow next, fast equals to fast next next. And after that, if my slow equals to my fast, in that case return true, else return false, else return false. So it's time for us to compile and run it. Hope it will work fine. This should not give any error. There has been some error, the typing mistake. So it is fast here. Okay, let us try to run it again. It is working fine for the 3 test cases given in the sample test cases. Let us try it for submit as well. It is working fine. So thank you for watching, and we'll meet tomorrow with a new video with a new lecture. So stay tuned. And if you're not subscribed, so please subscribe to my channel. Okay. Thank you. Have a nice day.